Hey guys, it's Adam Beaker, the science tutor, and today we're going to be talking about hybridization and the importance of it. And I just want to get straight to the point, but hybridization is important for molecular geometry and the way in which you can see the molecule, or the way in which you envision it with your imagination. So it's unlike most videos. I mean, it's going to be talking about Sp orbitals, Sp2 and Sp3, and I'm just going to get to how you can identify them quick. Easy ways to do it. I know easy trick I'm about to show you guys, and then we're going to use a real life or real test question problem to identify the different hybridization parts. So Sp, Sp2, and Sp3. So I'm just going to go right here, and I'm going to give you guys really easy ways to notice what it is, which one's which. So this one's an Sp, this one's a Sp2, and this one's a Sp3. How I do it is I look at the entire molecule. You have to be careful and tricky because sometimes on test questions the carbon has always 4 bonds unless it's notified. So always count the bonds with hydrogens as well, even if they are not shown. But for this one, carbon has all 4 bonds, so it's happy. So we know that there's no other attachments. And you simply add, or you simply put the equation like this. There's an S orbital right there, there's a P. So that's Sp. So lone pairs, they count as 1, so you have S. There's another bond, Sp, and then this is your P2. So Sp1, P2, Sp2. Here, it's a tetrahedral, so we'll see there's S for 1 bond, P1, P2, P3. You see what I did there, right? Sp3. There's always just go 1 S, and then you count your P's upward. So that's with each bond angle. So even if there's a triple bond, so even if I had something like, even if I had something like this, where I have a C, and a triple bond, this one I would still only put 1 S here, and that's a P1, so that's a Sp. I hope you guys see what I'm doing here. It's pretty simple, but you're just going to put, every time you see an attachment, even a lone pair, but 1 of those. So you start off with S, of course, so you always want to get your S out of the way. S, P1, P2. Done. That's simple. The carbon's happy, so you know that there's nothing hidden. So let's go ahead and start this real problem, and I'll show you guys how to do it. I want you guys to pause the video, of course, look at the attachments, see what's where, and see if you can figure it out on your own. But we're going to start and see what we can find. So let's start with this oxygen over here. So oxygens are happy with 6. So we have 2, 4, 5, 6. So we know there's no hidden attachments, hidden agenda from the test community. So this one we're going to put an S for this one. Put P1 for this, P2 for this one, and a P3. So we know this oxygen right here is Sp3. Okay, what about this carbon? So there's a S right here. There's a P1 right here for this additional bond to this other carbon. But this is one of those tricky test questions where the carbon, we know that carbon's like 4 bonds. I talked about it in video 1, which is down below, and you can click the link if you cannot remember. But carbon's like 4 bonds. So what it's not showing us, which does not have to show hydrogens. Remember that in skeletal structures that the hydrogens are not needed to be shown. But there's 2 hydrogens right here. So it's a Sp1, P2, and a P3 hidden, but this is an Sp3. And you have to watch out for this because they don't always have to put the hydrogens, yet you always have to know that there are 4 bonds in a carbon. It's single bonds, so it'll be an Sp3. It's also tetrahedral. We'll get into molecular geometry next video, and there I will show you exactly what's more of the importance and how you can identify the molecular geometry through the orbitals. So this one's the Sp3. Now this carbon has, one of the examples I showed you, it has one right here, so this is it, or one right here, this is your S. Anyone could be S, anyone could be P. You just want to number them off, so it's S orbital, and this one's a P. So, and you know that carbon's active with 4 bonds unless it notices, or unless you see a negative or positive bond or charge, you don't have to worry. So it's an Sp, so you know that's Sp. There's only P1, so it's Sp. This carbon, I'm going to give you guys some time, go ahead and try it out. So, hopefully you got it, but you know that carbon has 4 bonds, so this is 1, 2, 3, so we know that there's a hidden H. It was not shown to us, so we don't want to just say, okay, well this is S. No, this is Sp, so it's an Sp, or this would be your S, this would be your P bond. So fairly simple. I went over that pretty quickly, so rewatch it. If you have any questions, please leave a comment on the bottom, or if you have a question, subscribe so you can see my next coming video on molecular geometry. And remember that Sp will have 2 bonds for a carbon. Sp2 will have 3 bonds. Sp3 will have 4. So it's that's kind of messy, but it'll have 4 bonds. So you just count them off. It's fairly simple. It's an easy way you can look at things. So you can automatically count S, P1, P2, P3, and it's all from molecular geometry, which I'll show you next video. Thank you guys very much for watching. Do it for you. As always, there's a section of notes for you at the bottom. Click on the document, load it, print it, and it'll be a place where I'll put up more questions, and it'll be a straight study guide for you guys with my tips and anything else. Thank you guys very much. This is Adam Beaker, the Science Tutor. Appreciate it.